Okay, welcome to my first video. We're going over what in some places would be considered Math 090. This is just basic math, basic college math. So this would be the most basic math course that you would take in college. What we're going to go over in this first video, I'm going to try to cover these in about I'll try to cover them in about 10 modules. This first module, this is module 1, we'll go over what they would go over, and your class would be whole numbers. So whole numbers, if you broke that down, what would be describing is basically place value, the names for those numbers, addition, subtraction, multiplication, division, rounding, the basics of rounding, and then we'll go over maybe some application problems, and then we'll discuss order of operations. There is an airplane outside my house, but anyway, so what we'll do is let's start with place values and the names for numbers. So what I'm talking about when we talk about place value is where particular number is in a number. So what you may have, for example, let's just type out a number here. Font size is not big enough. We'll do 1 inch. Let's type a number. Let's say 542. So we have the number 542 here, and what I mean by place value is where is a particular number within a bigger number. So in the number 542, you have the number 5, the number 4, and the number 2. The 2 right here is in the what is considered the ones spot. So that is the ones place. Then we have the number 4 here, and that number 4, let me write these as I go. Ooh, that's horrible. We may have to fix that font size there. So this is the one spot, and then you have the number 4, which is in the tens place. Okay, and some people may call it tens place, some people call it tens spot. Well, typically we're talking about place value. We're going to talk about what place that number's in. So we have tens, we have ones. So that 5 there is going to be in, you guessed it, the hundreds place. See if I can sneak the word hundreds in here. Hundreds. So that's in the hundreds place. Okay. So we have 542. We have the 5 in the hundreds, the 4 in the tens place, and the 2 in the ones place. And then you would keep going. Now, let's say we put a 1 in front of this, it would be in the thousands place. And then a 2 in front of that 2 is in the 10,000s place. So it's kind of builds on itself, and you can kind of guess what the place, if you didn't know what the place was right offhand, you could kind of guess it by using the number 1. So we're going to use the number 1 as kind of the name value. So if I had a number, let's say I had a number 1, 1, 1, 1, 1, and I will put a comma here. So if I had that number, 11,111, and I wanted to know, I could define each place that each one was in, and you would do this by saying that one, the first one, this one, is in the ones. Let me get my circle. Here it is. This number 1 is in the ones position. Each of these positions is basically named after the 1. So if you're trying to guess, or you're trying to say, okay, well, this one right here, which place is it in, you could take that number and put a 0 after it. So that number would then become 11,110. So we would say, okay, well, that second one is in the 10 spot because that's just a 10. What about that? The third one, this one right here. Well, this one right here is in the hundreds place or position. And what I could do is just say, okay, well, 11,100, well, that is in the hundreds place. Okay, and then keep going left. You have a 1,000. We'll make that 11,000 and said that 1,000, the fourth one from the right, moving left, that one is in the 1,000s position or place, or thousands place is what you would say. And then the final one, all the way here at the very beginning, that one is in the 10,000s place because it's 10,000 if you take out all the numbers behind it. So that's basically place and place value. When we speak about the names for numbers, that's basically what we mean. That number's in the ones position, that number's in the tens position, etc. That would be what we would be talking about when we say names for numbers. Okay, now we are, since this is module 1, talking about whole numbers. So we probably should define what a whole number is. A whole number is different from, let's say, natural numbers. Natural numbers are your counting numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any number that you can count. So we typically would call the natural numbers counting numbers. Now, whole numbers include 0. So that's the difference. Natural numbers, I should probably edit that out because I'm not sure. I'm pretty sure that's the difference. Natural versus whole numbers. I'm going to do a Google search real quick and find out. Natural numbers are the set of positive integers, the integers from 1 to infinity, and whole numbers include 0. So that's basically what, I think that's what I said. So natural numbers are all the numbers starting from 1 and moving positively. And then you've got whole numbers. Whole numbers include the 0. So basically natural numbers are all the whole numbers excluding the 0. And then whole numbers are 0, 1, 2, 3, all those numbers, no negative numbers. When we talk about whole numbers, we're not discussing any negative numbers. When you start discussing negative numbers, that gets into integers. And we will talk about integers later on when we introduce fractions and negative numbers. Moving on with module 1, speaking about whole numbers, we're going to talk about addition, subtraction, multiplication, and division. And right now, I'm going to go ahead and white out my screen here. Give me 1 second. Okay. And we're going to talk about addition, subtraction, multiplication, and division. Okay. So with addition, that's adding two numbers together. So in addition, you take two numbers and you're going to add them to one number to another number. So for instance, 1, and let me change my color back to black. 1 plus 1. So we're talking about addition, and that equals 2. And since it's a whole number, we can count those numbers. So they're countable. You can count it on your finger. 1 plus 1 is 2. And since we're dealing with whole numbers, we can also throw in a 0 and do 1 plus 0 equals 1. Now, that's addition. Addition is taking two numbers and adding them together to make a bigger number. You're always going to end up with a bigger number than your other two that you started with. Now, when we speak about integers, we'll be able to do addition of negative numbers, and that same rule won't apply to negative numbers. In other words, if I add two negative numbers, I may end up that's basically the same application. You're going to end up with still a bigger number than the two numbers that you started with, unless you add a negative number to a positive number. Then, if your negative number is bigger than your positive, you'll end up with an answer that's less than one of your numbers. But anyway, that's technical stuff, and we won't get into that right now. So that's addition. Then we have what's called subtraction, where we take one number and we'll subtract it from another number. So we read this as 1 minus 1, or 1 take away 1, which of course that equals 0. Or you could have something like 5 minus 2, and that of course equals 3. Where's my equals? Oop, I clicked out of it. Equals 3. Okay, so that's subtraction. Now, I'm going to throw a curveball here, and I'll tell you something that most people won't tell you, and that is that there's no, in all technicalities, and we're going to get into real deep critical thinking here, so I want you to think about what I'm about to say, but in all actuality, when we talk about multiplication and division, there's really no such thing as multiplication and division. And what I mean by that is, yes, we can say stuff like 1 times 2 equals 2, okay, or 2 times 2 equals 4. So that is a real concrete thing, but really multiplication in and of itself is an abstract idea, and that it doesn't really exist. It's really just addition in disguise. So when you look at multiplication, it's really just addition. And so if you get to a point where you can't multiply something, you can actually break that down and add it, given the two terms that you're given in the multiplication, and you can get the same answer. So if you're ever proposed, let's say, just as an example, we were given 2,450, and if I would do it in black, you could see it. All right, and we wanted to multiply that, and what I'm going to use to mark multiplication is an asterisk. It could show up as an asterisk, a dot, or just a simple X, and that would be multiplication. In higher college courses, you're going to more often than not see multiplication denoted as a dot, and a lot of times it will be also denoted, and I'll go ahead and show you all the ways that it can be denoted. I can't do a dot, but you can also do it this way, and we're going to use 2. So 2. Okay, you can also denote it with parentheses, so that implies 2,450 times 2. Okay, that's another way you can write multiplication. And like I said, there's also, and you will see this less and less as you move on, but 2,450 times 2 with an X, you'll see that less. You're probably going to see it very sparingly in this course as this course evolves, because you'll start using what are called variables, and X is a very common variable. We won't get into that. You're going to see the first two more often than not in the rest of your math courses throughout college. Now, what we're doing is 2,450 times 2, and my point is, let's say you didn't know that right off the top of your head. A lot of people, I'm not a calculator. There's not very many human calculators that I know. So I would have to sit here and do it step by step. 2 times 0 is 0, 2 times 5 is 10, carry the 1, 2 times 4 is 8, plus 1 is 9, 2 times 2 is 4, so you've got 4,900, right? That's the answer. but I had to go step by step, multiply each number individually, you know, all that good stuff. Really, that's just addition, and I'm going to show you how. What you do is you take that first number, 2450. Now, the first number is not always going to be the biggest number. So what you want to do, generally, a general rule is, if you're going to do it this way, take the biggest number, and we're going to use the smallest number to know how many times we're going to add that number. So I'll read this as 2450 times 2, which just means, in addition, 2450 plus 2450. We're basically going to add 2450 to itself 2 times. 2450 plus 2450. Okay? And then it's simple. Then you can actually stack it, because in addition, you can stack things. And my plus isn't showing up for whatever reason. Yep, there it is. Plus 2450. Okay. And there's my little line for equals. I'm going to upgrade to a pen here one day. 2450 plus 2450. Go ahead and delete this out of the way as to not be confusing. And then now we can just do simple addition. So 2 plus 2 is 4. Still not working. 2 plus 2 is 4. 4 plus 4. Oh, I'm sorry. In addition, you work right to left. So 0 plus 0 is, of course, 0. Then we have 5 plus 5, which is 10. We have to carry that 1 over to above the 4. So we'd have a 1 up here. Plus 1. 1 plus 4 is 5. Plus 4 is 9. So now we have 9. Oops. Now we have 9, Alex. Okay. And then finally, 2 plus 2, which is 4, 4,900. So 2450 times 2 is 4,900, or 2450 plus 2450 is 4,900. That's multiplication. It's basically addition in disguise. Division is basically, I'm not going to say subtraction, because it's not. It's kind of, division in and of itself does exist in a sense, but it's really just multiplication in disguise, which really then there again is addition in disguise. So what you say, for instance, let's keep with this example, or this number rather, and let's take 4,900 and let's divide it by 2. Okay, so here's how you would denote division. /2, it can also look like a fraction, 4,900 over 2. But right now we're saying 4,900 divided by 2, and what we're saying is we want to divide that. Well, all we're saying is is what number times 2 gives me 4,900, or in other words, what number do I have to add to itself twice to give me 4,900? Okay, we already know it's 2450, but how would we figure that out just by addition? I'm going to go ahead and tell you right now, you wouldn't. So division is one of those things that you just have to going to kind of do. So you would say 2. I have no easy way of denoting division. So we're going to say 4,900 divided by 2. You would start by saying 2 goes into 4 2 times with nothing left over. 2 goes into 9 4 times. You have 1 left over. Carry down the 0. You have 10. So 2 goes into 10 5 times with a 0 left over, because 2 goes into 0 0 times. So your answer is 2450. Okay, and that's just division. And now the thing about division is you could check yourself by taking that 2450, that answer you got, multiplying it times 2, and if you get the bigger number 4,900, you know you've done it right, which we do know from our example previous that 2450 times 2 is 4900. So we know that is correct. Okay? And that's division. That's all there is to division. Rounding. Rounding is useful when you need to add whole numbers and you don't have to be exact. So you want to estimate what an answer may be, or you want to estimate, let's say for instance, you need to estimate how much money you'll have after you pay bills. Okay, that's like a real world application of rounding. Rounding works by taking a number. I'm going to give a pretty big number here, and this is where place value comes into play, because what the questions will ask you are, take 12,739 and round it to the hundreds place. Well, if you don't know where the hundreds place is, you can't round it. Okay? And in this example, 12,739, we know that the hundreds place, the 7 is in the hundreds place. If you get a question that says round to the hundreds place, that means you're going to look at the number in the hundreds place, the 7, look at the number behind it, 3. Okay, if that number behind it is 5 or greater than 5, then you would round the number from 7 up to 8. If that number is less than 5, let's say 4, 3, 2, 1, or 0, then you're just going to make that number a 0 and leave the 7 as is. Okay, but now what happens in rounding is, and this is a perfect example, if the number behind the hundreds place is not big enough to round that number up, then all numbers behind it go to 0. Okay, so that's what's called rounding down. So if I said round to the hundreds place with this number, 7's in the hundreds place, the 3 is less than 5, which means it doesn't round the 7 up, and we actually have to round it down. Well, what happens to the 9? Okay, the 9 too, it goes away as well. It goes to 0 as well, so now we have 12,700. That's rounded to the hundreds place. Okay, so what if I said, okay, round this number to the thousands place? So now we have to look at the 2, because the 2's in the thousands. We look at the number behind it, which is at 7. Now 7 is greater than 5. So that means our 2 is now going to increase and become a 3. But now every number behind it becomes 0. Well, now Alex, why are you making every number behind that 0? Why are you doing this? Okay, it's in the name, rounding. Okay, what we're doing is we're rounding the number either up or down based on some sort of criteria. So in the first example, right up here, 12,700, I said round that number to the nearest hundreds place. Well, the nearest hundreds place to 12,739 is in fact 12,700. That's the closest whole round number to 12,739. And I guess it's all in the name, rounding. You know, we just want a nice round whole number. We don't want 12,739. That's not a, when we think about round, you know, and we look at that number, it doesn't seem round. You know, when you think round, you think zeros. Okay? Or, you know, plump, like a round orange, or a plump plum, you know, that sort of thing. So that's what rounding is. Okay, so go back. Let's say round this number to the nearest 10,000s place. Well, the number 1 is in the 10,000 spot. The number right behind it is 2, which is not greater than 5. So we would round this number down to 10,000. Okay, is it making sense now? Let's take that number one more time, and let's round it to the 10 spot. Okay, well, 12, 7, the 3 is in the tens position, or tens place. 9 is greater than 5, so we would round that we would round that 3 up to a 4, and drop the number down to 0, and now it's 12,740. Nice round number, rounded up from 12,739. Okay, so when you think rounding, think round numbers, a nice round number. Okay, and of course you can't say round this number to the nearest ones place because there's nothing about this is not a decimal, which we won't get into those yet either. Not right now. We're fixing to. I'm about to introduce you. No, we won't introduce you to decimals until module 5. So this is just module 1. So that's rounding. How can I apply this in the real world? Because our next topic of discussion is application problems. So let's go back and look at rounding. How do I apply rounding to the real world? Well, let's say I have some bills, and you can use this in real life. Okay. What I would do, and this is what I do personally, is I take my bills and I make it, let's say I get a power bill, and my power bill for that month is $259.78. Okay, and I know I'm jumping ahead and using decimals. Actually, let's give it a nice 259 whole number. Okay, so my power bill that month is $259. It was really hot that month. And I want to figure out, well, let's give some other bills. Let's say that that was the power bill. What's another bill we could have? $153 for my cable, TV, internet, all that stuff was bundled together. So that's my cable bill. Let's say my cell phone bill was $86 that month. And let's say that garbage pickup, because we get charged garbage pickup, was $42 that month. Okay. Now, what can I do with these numbers to make it easier for me to figure out what each of them is going to cost me? Well, generally what you would do, and this is a real world example, so what you would do in the real world, and this is what I do to figure out bills, is you would take those bills and round them up to the nearest whole number. In our instance with 259, we look at the ones place, which is it's a 9, and we look at the tens place, it's a 5, and we can actually round that number up to 260 because 9 is greater than 5. We round that bill up to 260. Okay, now our cable bill is only 153, so we're safe in rounding that number down to 150. Okay, with 86, that 6 is greater than 5, we'd round that up to 90. Okay, and then with 42, we can round that down to 40 because 2 is less than 5. You would do this so you could add your bills together easier. Now you have that 0 at the end, so it's easier to add all these numbers up. 6 plus 5, start with the 0 at the end. 6 plus 5 is 11, plus 9 is 20, plus 4 is 24, so that's 4. Carry the 2 over. 2 plus 2 is 4, plus 1 is 5. So my total bills, my estimated total bills for that month was $540. Well, you could say, Alex, how much different is that from the actual cost? If we took the actual numbers and added them up, well, let's do that real quick. 9 plus 3 is 12, plus 6 is 18, plus 2 is 20. Carry the 2, you got 5 plus 5 is 10, plus 2 is 12. Okay, so you got 12 plus 8 is 20, plus 4 is 24. 4, carry the 2. 2 plus 2 is 4, plus 1 is 5. Check that out. And I didn't even mean to do that. But as you can see, rounding my numbers, I got the same. This is just adding the numbers together. And when I actually took it and rounded the numbers up, I actually got the same answer, 540. Now that's not going to happen every time. I got extremely lucky when I made up those numbers. But you can see what I mean. Got extremely lucky on that, and I could explain how, but I'm not, because that would be way too much for this video. But that's how you apply that to the real world. And then of course you would always round up your bills, right? Because that's money that's going to cost you. Anytime you look at something that's going to cost you money, always round it up. For instance, $259, we'd round up to $260. It's just simple. Why wouldn't we round that up to $300? Well, $300, that's a big step. You know, $259 to $300, that's like a $41 step. That's a big discretion. Whereas with $259 to $260, you're only looking at $1 or a one number discretion. With 153, you're only looking at a 3 with 150. Whereas if I rounded that up to 200, now I'm at, about 45, whatever. That's a huge jump, and I'm actually going to show less money in the end that I get to keep. Okay, we're trying to get to as close as possible. But why am I rounding them up anyway? Is really my point. Why round up with bills and round down with money? Well, simple reason is because if you round your bills up and you estimate that you're going to spend about $540, but let's say I rounded it and it was $550. Let's just assume it was $550. Well, then I go to pay the bills and I actually have $10 more than I estimated. Come out to the good. Makes you feel good about yourself, doesn't it? And when you take your monthly income for that month, you would round down, okay? And you have the same philosophy. And what you can do is with those rounding those numbers down, you can take that money that you estimated that you actually end up keeping, those 10 extra dollars, put them in a savings or something, okay? But let's go and look at your paycheck, because we're going to round that down, okay? Let's say you got 2 paychecks for that month. One was $843 and the other was $867. All right, take that first number, round it down, okay? In other words, no matter what is in the one spot, we're going to round it down to 0. So we're going to say 843 is going to be 840 anyway, looking at that 3, but look at 867. That would technically, if we were rounding up, we would round that up to 870, right? But I said to round down. Okay, well that means using the one spot, round it down. Well, if I say round down, well, I'm just gonna drop that last number, round it down to 860, because I used the word down. Okay, and in any sort of that, and that's a real world application, but you would apply that to any sort of math test or any math problem you would have. If it says round down to the nearest 10 spot, you're going to take that 860, look in the tens and say that's a 6, and you're just going to drop that ones place down to a 0, rounding down. Rounding down is actually a lot easier. What if I said we'll round it down to the nearest hundreds? Well, 867 rounded down to the nearest hundreds is 800. Okay, that's the nearest number to 867 if I round down. If I round it up, the nearest number would be 900. It's the closest number to it, rounded up. But that's a real world application. We're applying that. Bills, we're going to round up, so we would actually overestimate what our bills are going to cost. And with our income, we want to underestimate, because then when we take those two numbers and put them together to find out what our what our loss is, we actually come out to the good either way we look at it. Okay, so 840 plus 860 is $1,700. Okay, and that's rounded. Now you actually came out making more money than that. You came out, let's see, that's 10, 11. you actually came out to about $1,700 and $1,710 total. But you lost 10 of those dollars rounding your income down. Well, you didn't lose those $10. You did on paper, but you're actually going to make those $10. So then when you go to take out that $540 for bills, and you come to find out that you're going to have $1,160, but you actually have $1,170. See what I'm saying? It'd make you feel better about it. Okay, and then we talk about, well, that's rounding, and that's, applying it. All of these things, addition, we just added, so that's applying addition and applying rounding in the real world. That's our application problem. But the last thing I want to talk about in module 1 is order of operations, which is, and you may have heard this before somewhere else, please excuse my dear Aunt Sally. You may have heard that back in grade school, okay? Or if you're watching this video and you're in grade school, you may have heard that, in your math class. And you were like, well, what is please excuse my dear Aunt Sally? PEMDAS. Please excuse my dear Aunt Sally. And what that is your order of operations. It's an easy way to remember your order of operations, which are, the P stands for parentheses, E is exponents, M is multiplication, if I could spell right, multiplication, D is division, A is addition, and S is subtraction. Okay? PEMDAS. Please excuse my dear Aunt Sally. Now, take a drink here. Now, what is the order of operations? Well, it's what you would use if you were given a problem and it was a long problem and it had all of these things in that problem. This is the order you would take in order to solve that problem. So let me give you one. Now, this is not going to be something that you would face or you would see in a module 1 course. You would not see this the first week or the first 2 weeks of class. You have not yet been introduced to fractions. We haven't multiplied fractions. We haven't even looked at decimals yet, okay? Or exponents for that matter. So don't freak out when you see this. But I wanted to show you what it's going to look like. Times 3 plus 2. Alright, we'll use the caret because I can't do superscript right now. Minus 5 plus 2. And let's do this. If I'm going to do it, I might as well just go all out and confuse the crap out of you. Just right off the bat. Now, I made this up off the top of my head. We're not actually going to solve it. Or actually, we might. I don't know. Let's find out, because that dividing by 3 may give us some weird number. And that's what I'm afraid of. But let's look at PEMDAS. Let's look at please excuse my dear Aunt Sally. And let's see how that applies to what I just wrote out. Now, if I read that out loud, what I'm asking you to do is I'm asking you to say 9 plus 2 times 3 plus 2 to the second power minus 5 plus 2, all of that divided by 3. So we're going to divide everything divided by 3. Now, why would I divide everything by 3? Well, because it's in parentheses over that division symbol. So that means we're going to do all this first because it's in parentheses and it shows up first in our PEMDAS, parentheses. So we know just by looking, we're going to solve everything in here within those parentheses first. Okay, when you also see there's some more parentheses in here. And yes, you're correct. We are going to do those first. And this little caret right here, that actually means raised to the second power. Okay, so this is an exponent. Okay, I just want you to look at it that way. And I know we haven't really discussed exponents yet. We will later. All right. So parentheses. So I have to do everything in parentheses. So within those parentheses, there's other stuff in parentheses. That 9 plus 2, for example, is in parentheses. Well, what is 9 plus 2? Well, 9 plus 2 is, of course, 11. And then we're supposed to take that and multiply it times 3 plus 2 to the second power. But look at 3 plus 2 is in parentheses. So we're going to keep those parentheses because we're denoting that it's raised to the second power. But we're going to do the 3 plus 2. All right. Keep writing it out. Minus 5 plus 2, still in parentheses, and it's still being divided by 3. All of that. We're not done with our parentheses yet. We still gotta finish out everything that's in there. Okay. But we have this, and that's our next point, which is exponents. Okay. Got to do all the exponents first. So we've got that 5 to the second power, which 5 squared is 25 because it's just 5 times 5. So 11 times 25, oops, there's our exponent, minus 5 plus 2, and I forgot my parentheses, but we're going to put that in parentheses and divide it by 3. Okay, now I should have mentioned this earlier. I'm going to go back and mention this now. But when you have parentheses, okay, and then you have parentheses within those parentheses, we're actually looking at what's inside the parentheses and applying PEMDAS inside of those parentheses. So we have to go and say, okay, there's parentheses. Let me look in the parentheses. There's more of them. I got to do those first. Okay. Then, while I'm still in the parentheses, within these, I've got to come in here and apply the order of operations to what's inside the parentheses. So I have to do the exponent next because that's PE exponents to the exponents. Got to look back in the parentheses again, and I see that we don't have any more parentheses. We're done with our exponents. Let's move on and let's see if we have any multiplication and or division. Okay, and why I say and or is because when you get down to the MD and the AS part of PEMDAS, you can actually do multiplication and division in any order, or whatever order seems, to fit. In this case, we don't have any division within the parentheses. We just have multiplication. 25 times 11. And give me a moment to figure out what 25 times 11 is. It is 275. So we have 275. Okay, that's 11 times 25. Did the multiplication first. So minus 5 plus 2. All of this is divided by 3. Still in parentheses. Let's go back in there. And now let's do the addition and or subtraction. Well, we've got 275 minus 5. That's doing first. That's 270. I'm going to add 2 to that. Divide that by 3. 270 plus 2 is 272. Divided by 3. Now I no longer have to write is the same. I no longer have to write 272 in parentheses anymore because it's done. We're done. So 272 in parentheses, that's the same as that. 272 divided by 3. Okay? And what is 272 divided by 3? Well, let's see. 3 goes into 27 9 times with nothing left over, of course. And then it won't go into 2, so you've got 90, and you're going to have probably have a repeating decimal place because 3 goes into 26 times with 2 left over, 0. Yep. You're going to have a 6 repeating. So the technical answer to this is 9.6 repeating. I can't do the repeater bar. This is going to be 90.6666 repeating. Okay, that's the technical answer to this question. I would say round it to the nearest ones place, so 91. And I know once again I'm confusing you because we haven't done decimals yet. We'll do decimals in module 5. but just take my word for it that when I say round to the nearest ones place, then we have to take the first digit that appears after the decimal, greater than 5 it is, and round that number up to a 1. And then all of our decimals go away. Okay? So just trust me. 91 is our estimated answer for 272 over 3. But I was just wanting to illustrate, what is PEMDAS. This is PEMDAS. This is, please excuse my daring Sally, order of operations is what this is. Okay? And remember, we started with this up top, and we actually reduced it down using order of operations and got an estimated answer of 91. That's it. That's it for Module 1. That is Basic Math, Module 1, Whole Numbers. You've learned place values, names for numbers. You've learned what addition, subtraction, multiplication, and division using whole numbers. Rounding, we've seen rounding. How we could apply this in real world problems. And we've just discussed order of operations. Module 2 will be an introduction to fractions. We'll look over an introduction to fractions to include the proper fractions, improper, and mixed numbers, and what equivalent forms of fractions are. We'll also look at factors, prime factorization, the greatest common denominator, and the least common multiple. We'll learn about that in our introduction to fractions. That'll be Module 2. Thank you for watching. I'll see you in Module 2.